All right, guys, so since we don't have class today, I'm going to record some videos to sort of take the place of our class. Now, this won't cover everything, so you'll also need to make sure that you're looking at the other videos like from Khan Academy and other places that I put on our D2L course website. Use the resources in my math lab, read your textbook, and if you're having troubles, come and talk to me. All right, so for those of you who haven't made it to campus today, it is our Grease event, so you're missing out on people wearing things like poodle skirts. But let's go ahead and talk about inverse functions. Okay, inverse functions. What does inverse mean? Well, an inverse is an opposite or an undoing action. Okay, so the inverse of day is night. The inverse of up is down. Now, when we're talking mathematically and we're talking about inverses, inverse functions undo one another. All right, so mathematical inverses undo one another. Now, what does that really mean? Well, I bet you can think of some functions that undo one another, or some operations that undo one another. So for example, addition and subtraction are inverse operations. So what does that mean? Well, if I start with something, say 7, so this is my starting point, and I add 4, and then I do the opposite or the inverse, and I subtract 4, well, these two essentially undo each other. Adding 4 and subtracting 4, those cancel out, and I'm just left with 7. So mathematical inverses are opposites. Now, often we don't start with a 7 here, but we're talking about doing this with a function, okay? So if I start with x, and I add 4 and then subtract 4, well, I'm just left with what I started with. I'm just left with x. Now, oftentimes we want to talk about functions, or want to talk about inverses as functions. So let's say I start off with a function, f of x equals x plus 4. Now, if I want to find the inverse function, there's several ways of doing this. We're going to try and do this conceptually and intuitively to start with. In a later video, we're going to go through a step-by-step process to find the inverse of any function that has a functional inverse. But here, the opposite of adding 4 is subtracting 4. So my inverse function should be x minus 4, plus 4 minus 4. Those are inverses. Now, mathematically speaking, we want a way to talk about the inverse that doesn't involve me writing inverse function. Mathematicians like shortcuts for things like that. So we're going to use the notation f with the little superscript -1. This means the inverse of the function f. Okay, so these two functions are inverses. What one does, the other undoes. Now, inverse functions have some really cool properties. So we're going to talk about those properties graphically, so looking at a graph, and we're also going to talk about those properties in terms of composition. But before we do that, I want to talk about some other inverse functions. Okay, all right, so I'm going to move these two functions over here so that we have a list of inverse functions. So if f of x is x plus 4, the inverse is x minus 4. All right, let's pull another function up here and see if we can't come up with its inverse. So let's say I start with the function g of x equals x cubed. Okay. G of x equals x cubed is a nice function. Now remember that an inverse is an undoing action. So we're thinking about what undoes cubing. Well, what undoes cubing is the cube root. So if our starting function g of x is x cubed, our inverse function, which we're going to write as g to the -1 of x, is going to be the cube root of x. So here's another pair of inverse functions. Okay, now I want to talk about one third one, and this one gets a little bit weird. Okay, so a third example that I want to talk about is we did the x cubed function. Let's look at the x squared function. Well, if we're thinking about inverses as undoing processes, the squared function is undone by the square root. So it seems to make sense that x squared and the square root are inverses. And this is sort of true. We're going to run into a little bit of an issue here because of something called whether or not a function is one-to-one or whether or not it passes the horizontal line test. So I want to think about this example, okay, as we move on. So I'm going to write this guy over here. So h of x equals x squared, h inverse equals square root. But I'm going to kind of look at this and put a little question mark because we need to investigate this one a little bit further. Okay, all right. So we have some examples here. And I want to talk about a couple of different things with these examples. The first thing I want to do is I want to talk about another meaning of inverse functions. So another meaning of inverse functions, besides the undoing function or the undoing idea, is inverse functions are reflections Now we've talked about reflections before. I can't spell reflections. Okay, we've talked about reflections, namely we've talked about reflections across the x-axis. So x squared compared to negative x squared. Well, inverse functions aren't reflections across the x-axis or even the y-axis, but they're reflections across the line y equals x. Okay, so what does that mean? Well, what that means is if I have a little graph here, okay, I can put in the line y equals x. So that's that, just this straight line here. This is y equals x. Okay. And reflecting something across this line, right, means that it has to match up on both sides of that line if I were to fold along this line. So I want to take this idea of inverse functions as reflections across the line y equals x, and I want to consider both, or all of these pairs of functions and take a look at what happens. Now I could graph that on the board, but you guys have seen me graph, so instead I'm going to come down here and I'm going to share my screen with you, and we're going to do this using an online graphing utility. All right, so you should now be able to see Desmos here. So I'm going to graph the function x plus 4. Remember that was that first function that we looked at. It's just a straight line, has slope 1 over 1, has y-intercept of 4. Now I said that the inverse function is x minus 4. Okay, so there in red is x plus 4, there in blue is x minus 4. Now I also made this claim that inverse functions are reflections across the line y equals x. So there's our line y equals x, that green line. Now if you can imagine folding along that green line, the red line and the blue line would match up. That's what it means for x plus 4 and x minus 4 to be reflections across the line y equals x. That also is another way of showing they are inverses. So let's take another one of our examples. We also had x cubed. So I'm going to change that first line to be x cubed. So there's the graph, x cubed. Now I want you to take and see if you can use your imagination. I'm going to zoom in a little bit and imagine, okay, if I folded along that green line, where would my reflection end up? I think of this as like those ink drawings you may have done in like preschool where you painted on one side of a paper and then you fold it in half and you got a perfectly symmetrical drawing. So take a minute and picture what that might look like. All right, so there's our blue graph. The blue graph is the cube root of x. Notice I've entered it as x to the 1/3. That's the same thing as the cube root. And look, x cubed, the red line, and x to the 1/3, the blue line, certainly are reflections or mirror images across that line y equals x. So again, that's telling us that our inverse is a reflection across the line y equals x. Okay. Now I want to talk about the one that I said was weird. And so to talk about the one that I said was weird, that's that x squared graph. Well, there's the graph of x squared, Okay. Now again, I want you to take a minute and I want you to picture what it would look like if I were to reflect it across the line y equals x. All right, you have it. I'm going to do two things here. Now to get an actual reflection, okay, there would be my actual reflection. Can everybody see how our parabola, that red parabola, when reflected across the green y equals x line would give us that blue line? Now there's a problem with that. The problem with that is our blue function, if I take everything else away, our blue function is not a function. I called it a function, but it's actually not a function, right? It fails the vertical line test. Okay. Remember, the vertical line test says if I draw a vertical line somewhere, say at x equals 1, I'm going to pass through this function twice, and I certainly do. So our blue graph does not pass the vertical line test. Now, I want us to think about that in relation to our original graph up here. Okay. Now notice, if the reflection, the blue line doesn't pass the vertical line test, it actually means that my original line, my red line, my original x squared function doesn't pass the horizontal line test. This is what's known as 1-to-1. Okay, so if a function is 1-to-1, it passes the horizontal line test, and what that means is that we get a functional inverse.